In this video, I'm going to show you how I built a smart WhatsApp assistant for my landlord client. Now, in this day and age, a lot of people think that property is passive and nobody needs to do anything once the tenants move in. But you have that edge case of the landlord who cares about their tenant and wants their tenant to have a wonderful time whilst living in their property. You might think everybody has that idea and has that opinion for their tenants. But in this case, my landlord client has a new set of HMOs coming up on the market, and his thinking is that whilst the tenants are living in the property, he wants them to be able to communicate with him in a reliable and intelligent way. And guess what? He is using AI to make this happen. So let me talk you through the solution that I built, and then we can look at how it looks when it's implemented fully. So imagine this: you've got a client or a tenant on the left hand side here. He's got a smartphone with WhatsApp installed. So he sends a message, for example, what is a Wi-Fi pin? That message goes from his phone to WhatsApp, and then from WhatsApp, the thing that we've implemented for this landlord is a Twilio backend. So from WhatsApp, it goes to a Twilio phone number that he has purchased. And this Twilio phone number and the configuration behind the scenes has a sender. The sender is essentially the phone number. That sender then forwards the message to a webhook. So a webhook is essentially like a website or an endpoint or an API that receives the message that the tenant has sent. In my case, the webhook is actually an Nginx reverse proxy. What does that mean? It just means that you have a system in the front end that receives the initial message, which is the API or the endpoint, and then that system, which is an Nginx proxy, then determines based on the path of the request where to send the request to. So what is a Wi-Fi pin gets forwarded through Twilio and then through Nginx. Nginx then says, okay, where is this headed? Oh, it's headed for the chatbot. It then goes into the chatbot. Now in this case, this chatbot is a program that's running in the background, and I'll show you that in the code. So that's a program that's running in the background, and when the chatbot receives this message, it then pulls out the relevant information that I need. And that relevant information, so this is a chatbot here, and that relevant information is essentially the phone number and the message that has been sent. What it does next is really clever. It then looks in a database, in our case is a Redis database, and that's because Redis is a memory bound database. It lives in the memory, so it's really quick to query that database and get the results back. In that Redis database is the messages, any previous messages that have been sent by this particular phone number, and any responses that it has received through that conversation. So it queries that database, it takes the prompt, there's a system prompt in the code which it then combines to then send off into the N8N webhook. So we've got two webhooks here. The first webhook is a chatbot, my chatbot code, extracts a phone number, collects the system prompt, collects a user prompt, and collects a history from that phone's previous sessions. All of that information is passed to N8N. Now in N8N, the webhook receives all those fields, and then from those fields it sends a query to the CRM. In this case, the CRM is an Airtable table, and in that table is looking for the phone number that it's received. Now that phone number must be tied to an address. So if it doesn't find a phone number or it doesn't find an address, then that's handled in a different way. But in this case, let's look at the happy path. So it receives a phone number, it checks the database, it says, all good, I've got an address. If it has an address, then the workflow carries on to the OpenAI message categorizer. The message categorizer is designed to try and determine the category of the kind of message that has been sent. So a message such as what is a Wi-Fi pin is not an urgent message. It's just a message that can be pulled from the knowledge base. If on the other hand the message is, oh, there's a leak in the ceiling, or there's a gas smell, then the message goes down a completely different path. In this case, the urgent landlord message. And then I'll talk you through all the different categories of messages that would come, and then we'll end on the knowledge base one. So starting on the right hand side, the message is categorized as an urgent landlord message. It then creates an email, and the email gets sent to the landlord, and after sending the email, it sends a request to the ClickUp application, and that ClickUp application creates a task, and that task lives on ClickUp, and that's used to track the request that's been sent and assign it to the landlord. So the landlord behind the scenes then has to address that task, either assign it to somebody or deal with that by himself. So that's one category. The second category is the repair engineer. So it'll be something like the kitchen is broken, the kitchen door has fallen off, or the lock, I've forgotten my key, I've lost my keys, something along those lines. If that is the case and it's categorized as a repair engineer, the request is sent straight into ClickUp, and then a message will be sent to the repair person, so the handyman that's looking after this property. And after one of those two things happens, you then send a message back to the happy tenant. So that's the happy tenant right here. Okay. The third category is the knowledge base category. So that knowledge base category would happen for things that we expect to see in the knowledge base. So what day would the bins be collected? What is the Wi-Fi pin? What are the manuals for the dishwasher, the washing machine? How do I set code on the washing machine? So all of that information would previously have been saved in the Supabase vector store. So that Supabase vector store holds all of the information, or all of the embeddings, as would be mentioned in a technical way. But that's where the information is. So that question that's come in, it's categorized as a knowledge base. Remember I mentioned that part of what we receive from the chatbot endpoint is the system prompt, and we also receive the user prompt. So this message will be inserted into the user prompt, and then the system prompt in combination will be used to query the message that was sent will be used to find out what is in the vector store and the best answer for that vector store, or for that question. So how it works in at a high level is that the message that comes in is also embedded or converted to ones and zeros, because the information in the vector store is also ones and zeros or hex. So using the embedding numbers or the embedding digits, you're able to find what matches closely to the question that's asked. So the number of chunks that match the question that's asked will be returned by the vector store. So then the vector store passes the closest matching documents or closest matching chunks, as well as the prompt and the question. All those things are then passed to the OpenAI LLM. So the OpenAI LLM receives the prompt, the chunks from this vector store, and the memory. This also has the memory, and it just so happens that it saves that memory in the same Redis database that we have up here. So you've got two chunks of memory that it receives, and that's there to give the LLM a bit of context as to how it needs to respond to the question. And then once the LLM receives all of that information, it creates an appropriate response and then sends that back to the phone. So that's it at a very high level. We've got ClickUp, we've got Redis databases, we've got Docker here, and all of this bits here are within the same virtual environment, within a Docker environment, and we've got different containers that handles different aspects of this solution. So I'm going to stop this right here, and then we'll move over to how the code was implemented. Okay, so welcome back. This is what the N8N looks like once it's been sent from the WhatsApp sender or the Twilio sender through to the chatbot endpoint or through the Nginx endpoint, and then gets forwarded and processed internally, gets processed first and then forwarded to this N8N endpoint. So this is what I was describing in the design diagram that we looked at earlier. So what does that look like here? Within the code base, I've got this code base that contains pretty much everything that we require for all of the containers to be set up correctly. Now, one of the things to bear in mind is that I'm using ngrok. Ngrok is essentially a way to make your laptop appear to be online. So ngrok receives all the requests and then forwards that request to my laptop, because my laptop is not on the internet, it's not an internet facing endpoint, or its IP address isn't. So the ngrok sits there and then receives the request, and it's almost like you have multiple proxies, right? Because ngrok receives the request, then forwards it to the Nginx here, this bit here, and then that Nginx, depending on the path, forwards that to either the N8N or the chatbot. So we have 1, 2, 3, 4, 5 different services that are running, and each one has its own very particular function. So I've told you what the ngrok one does. It receives the request from the ngrok service and then it handles it within the laptop. And then Nginx just sits there as a reverse proxy, determining where the bits of information should go. So this is an example of what the config looks like. So if the request comes in and it's a slash N8N, it forwards it to the N8N address, which would be the N8N container. If it's a slash chatbot, then it forwards it to the chatbot, to the slash chatbot container, and we'll have a look at that in a bit. So that's the Nginx config, as well as the Docker compose configuration. So these are the configurations that we use to spin up the containers. So the actual code that runs in the background comes through this main. This main gets triggered, and then my endpoint gets called, and when the endpoint gets called, it then goes through the process of handling the message from WhatsApp, extracting the phone number, extracting the actual text that was typed by the tenant, and then that information, as well as what it pulls from Redis, gets pushed to the Nginx endpoint. So these are the containers that get created. As I mentioned, there are 5 of them: N8N, Nginx, chatbot, ngrok, and Redis. So all of these running at the same time on the same machine and processing everything that I needed to process. So that is how everything sort of interacts. So just to recap what's actually happening, the Twilio sends or forwards the message to the ngrok endpoint, and that ngrok endpoint then forwards it to the Nginx. Nginx is a reverse proxy, which then determines if it's going to slash chatbot or slash N8N. If it's going to slash N8N, then it triggers this workflow depending on the path. If not, it goes to the chatbot. And here is what I was explaining in the design. So when the information comes in at this point, we're expecting okay, we've got nothing saved here. So we are expecting that specific fields come through. So when we're searching for records, remember I mentioned that this goes off to the Airtable database to extract something that's from the phone number. So this is the phone number. It looks at the phone number column within the property management and tenants table in Airtable, and then this is where the message categorizer takes place, and then based on the output from this message categorizer, this switch statement then kicks in, and the switch statement determines if it's urgent, which is where we create a draft email in this case, create a task, and then sends back to the WhatsApp device. If it's a repair engineer, it just creates a task and sends it on to the device. So all these three are responses after all the activity has happened. So the third one is the knowledge base, where we've uploaded different files and different items that would inform the request that will be sent back to the user if it's a knowledge base request. So things like the PIN and the bin day, collection days, and things like that. So if you look at the video at the beginning, I showed something that highlights how the responses go or how the requests are sent, and then the responses received, what it looks like in a visual sense. So this section down here would have to be the subject of another video, and let's not stretch this too long, but just at a high level, this is how the information gets loaded into the Supabase vector store. And what gets loaded is, if we have a look at drive, so with this one here, so these are all the files for this particular property. Suffice to say that it's built such that another property would have its own set of documents, and all of those will be loaded differently and separately, and will be returned in queries depending on where the tenant actually lives. So all of this is information that is part of the solution going forward. So this is it. This is the N8N workflow, and this is the code that we've written. Everything to do with the prompt is here. So the system prompt comes out from here as well, with all of our relevant instructions, and we provide examples as to what a response should look like based on the question. So it's a few shot query, and then here is where the tenant's message gets it replaces this tenant message variable with what the tenant has actually sent, and then all of that is bundled together and then sent onto the N8N. So just so there's no confusion, the N8N lives within the same network as the chatbot, so the chatbot can very easily query the N8N without going out into the internet and coming back in. So everything is together, and that's why it works really smoothly. It's very easy to deploy this in other environments as well, because it's all in one place. So that's it for now. If you do have any questions, feel free to put them in the comment section or reach out to me. Otherwise, just enjoy this, create it yourself. If you want a copy of some of this code, just reach out and let me know. I don't have a GitHub repo set up for all of this just yet, but suffice to say that it is working quite swimmingly well, and the landlord is happy with it. So if it's something that you want built for you as well, just reach out to me, and I will be sure to provide an equally superb solution to give you those peaceful nights and keep your tenants happy. Right, speak soon, keep shipping.